Hey everybody, I'm Mr. Hartzler, and I wanted to talk to you about my section 8.2, which is adding and subtracting rational expressions. And when we're doing that, we have to start off by looking at our LCM. We do that by looking at 12a squared b first. That's going to kind of be our first example. Then we're going to go into 12abc and so on. So we're over here. Let's look at 12a squared b. I want to split that up into as many little pieces as possible. And the 12 splits up to a 2. And, well, that's 2 times 2 gets me 4 times 3 will get me the 12. And then there's an a squared and a b. I leave those kind of a squared. I'll leave it like that. 15, we're going to do a similar thing. This one's going to be a 3 times a 5. And we have a, b, c. The 8, we have 2 cubed because it's 2 times 2 times 2. So up here, hopefully we've picked up on that pattern. I can do the same thing here. I'm going to erase this 2, and I'm going to change it to a 2 squared. And I have b cubed c to the 4th. Now I have to look at the largest number of each of these elements that all of these have. So let's look at 2's. My LCM is going to have 2, because, I mean, definitely at least 1, because this one has 2 of them. This one has 3. I need to pick the largest number there. Because I can build the other terms up to that one, I just can't tear anything down. It's kind of like how we should treat people. We're only going to build each other up. We're not going to tear anything down. So I can build up to a 2 cubed, because I can multiply this one by another 2. Well, then it's 2 cubed. And I can multiply this one by 2 cubed, and it's 2 cubed. I have 1, 3. That's my largest number of 3's, is 3 to the 1st. A squared, well, my largest one is a squared, so I'm going to leave that one up there. Largest number of b's I have, 1, this one has 1, this one has 3, so I'm going to have a b cubed. And here we have 1c, we have c to the 4th, so I have to go with c to the 4th. This is going to be my lowest common multiple. 2 cubed, which is 8 times 3, gets me 24, a squared, b cubed, c to the 4th. So this is what we have as our LCM. This is helpful for when we start finding fractions. Let's go over and do an example like that. So we're here. We have 4 over 5a cubed times b squared. Then we have 9c divided by 10ab, and we're adding these two fractions together. First thing I'm going to do with this is I'm going to find the lowest common multiple for our denominator. So I'm going to write out my two denominators. 5a cubed b squared. That one actually doesn't split up any more than that, but the 10ab does. It has a 2 times a 5ab. So my lowest common multiple is going to have a 2. It's going to have a 5. Even though this top one doesn't have a 2 in it, I'm going to build it up so that it does have a 2. And a to the cube, or a to the 3rd, and b to the 2nd. Those are our largest numbers of a's and b's. So this here is the denominator I'm going to be building everything up to. And so that's going to end up being my common denominator in the end. Let's change our color here. So I have 4 over 5a cubed b squared. And I'm going to have to multiply that by something so that I can get this as my denominator, which is, it also simplifies to 10a cubed b to the 3rd. Oh, sorry, this should be a b squared. B squared. That's our largest number of b's. All right, so what does this one need? What is it missing? Well, it has the a cubed and the b squared, but I need to get up to a 10, so I have to multiply this by a 2. Then I'm going to have my other fraction, 9c over 10ab. It's missing some stuff. It already has a 10. That's awesome. I should have an a cubed and a b squared, but I only have one of each. So I'm going to need to multiply by a squared and a b. Whatever I do to the bottom, I have to do to the top. That just keeps everything fair. Nobody fights that way. Now I'm actually just going to multiply those things and see what we get. We have an 8 over 10 a cubed b squared plus 9 a squared b, and then there's a c right there floating around, divided by, and now we have 10 a cubed b squared. Well, you'll notice those denominators are the same. So I can just have one giant fraction. 8 plus 9, a squared b c. And we are dividing by 10, a cubed b squared. So this is our final answer when adding up these two monomials. So hopefully this was helpful. And let's go on to the next one. We get a little bit more help in here. This one's a little bit more complicated. We're going to start off by factoring both of these denominators. Let's actually do that in red. So the x squared minus x minus 6. I'm actually just going to write that one right down. And this one factors. That's how we're going to break this one up. To an x minus 3 and an x plus 2. The next one, 5x plus 10. That one is also going to be split up into 5 and then x plus 2. So what's my LCM going to be, my lowest common multiple? Well, I'm going to need that 5. It's going to have to show up somewhere. And then I'm also going to need an x minus 3. And I'm going to need an x plus 2. Only one of them, even though it shows up twice. Right? I have one up here and I have one up here. They each only are going to need one. So let's go up here and change our color to blue. So I have an x minus 1. What's my denominator need here? Well, it has an x minus 3 and an x plus 2 in it. It's missing the 5. So I'm just going to write the factored version here. So far I haven't changed anything. Now I have to multiply by something, and the top and bottom are both missing the 5. Now let's subtract it because it was a minus 4. And again, I'm going to write the original down first. I'm going to write the factored version of it. So 5x plus 10, that's 5 times x plus 2. What is this missing that my lowest common multiple has? Well, it's missing the x minus 3, so that's what I'm going to multiply by. And on top and on bottom. Now, let's simplify a little bit of this. I'm going to distribute the 5 in. So I have, let's do kind of a gray this time, just for funsies. We're going to have 5x minus 5 over, and I'm just going to leave these all factored out. I don't have to distribute these in. Minus 4x. Now I'm going to distribute this whole thing in to both of these terms here. So it's going to be minus 4x plus 12. Oop. Let's get rid of that and let's try that one again. There we go. Over 5x plus 2, x minus 3. You'll notice again, my denominators should both be exactly the same. They are, except the order. The x minus 3 and the x plus 2 are switched, but that's fine. Commutative property of multiplication says I can change the order of those if I really want to. So I'm going to have these two things on top of the same denominator now. And this will be my final answer. So 5x minus 4x, that gives me 1x. Negative 5 plus 12 gives me plus a 7. And my denominator, again, I'm just going to kind of leave this as it is. If you feel the need, you can distribute all of that out. Keep in mind you will have to FOIL. And there it all is for this one. Now let's start off with complex fractions with different LCMs. So we have a numerator and a denominator, and within both of those we have even more fractions. Starting off up here, you'll notice, let's look at just the top, and we have a LCM of x. So let's get the numerator so that it has the correct LCM for everything in the top. So we have a 1 minus 2x. We need to get that both so that they're over the same fraction. Well, what's the 1 missing? Right now it has just a 1 on the bottom. We're going to multiply that by an x over x. And that is so the whole top will have the same denominator. So I have a minus 2x, that's staying the same. When I simplify this, let's change color up again to, let's go blue. So now I have an x minus 2 all over x. This is going to be nice because the whole top is one fraction instead of two separate things. We need our big fraction bar still. Now let's look at the denominator a little bit more closely. 3 over y minus 4 over x. Our common denominator for both of those is going to end up being an x, y. That's our LCM. What's this 3 over y missing? Well, the 3 over y is missing an x, so I'm going to multiply by an x over x. What's the 4 over x missing? Well, it's missing a y in the end, so I'm going to multiply by a y over y. And let's switch this back to blue. Let's fix this because it's the wrong color. And there we go. So our denominator down here is an x, y. Our numerator, 3x minus 4y. Now, you've seen this video already, or you hopefully have seen the other video already, but we have two fractions on top of each other. So instead of dividing by a fraction, we're going to multiply by this reciprocal. So we're going to have x minus 2 divided by x. That's our original numerator over here. I'm going to switch from dividing to multiplying. And this, instead of 3x minus 4y, I'm going to divide it by xy. We're going to flip that, or take the reciprocal. So now we're going to have xy on top and 3x minus 4y on bottom. So we took the reciprocal of this, and it's down here. Now I'm going to see if I can cross-reduce a little bit, and I can. I have an x on the denominator here and an x over here. Those are going to cancel out. So we are left with x minus 2 times a y divided by 3x minus 4y. And this is simple on top, so I can distribute that y in. And we'll have our final answer right here. X, y minus 2y divided by 3x minus 4y. This is our final answer, and this is the last example for this video. Hopefully this was helpful. If it was, please click that like button. It's going to be down over here. Subscribe to the channel and click the little bell thing. I don't think I can draw a bell, but click that little thing. I think it even has little sound movements. Click that little bell. I'm sure that's not what it looks like, but click that and you'll get notifications when I upload new videos. If you have a suggestion for a video too, if there's something in math class you want to see, or in my engineering classes, or any PUE or IED class, please let me know and I can make a video on that. Hopefully you guys all have a phenomenal day. Enjoy it.